Hello, my name is Ardi and we are going to solve practice problem 4.8 from Hayt's book. Determine I1 in the circuit of figure 4.24 if the controlling quantity of A is equal to 2I2 in the problem A and then 2Vx in problem B. Okay, we have two circuits here that nearly identical. The only difference is the value of this dependent voltage source A. Okay, so maybe we should start with I2 because they are the same in both circuits, right? So let's start by doing KVL at I2. KVL at I2. And KVL said that the sum of voltage in a loop will equal to 0. Okay, we will start from maybe this 6 volt voltage source and the current is flowing from negative to positive. So our sign will be negative. So minus 6 and then plus this one is 4 ohm, but we need to convert it to voltage. So we multiply it by I2. And then for this 5 ohm, so now we convert it to the voltage by multiplying by I2. But here, another current, I1, is flowing to the other direction. So we need to subtract I1 from it. So like that. And the last one will be this 3 ohm resistor. So I will have plus 3. And again, because we are converting resistance into voltage, we multiply it by I2. So all of this will equal to 0. And let's do some math here. So I will have minus 5 I1 from this term. And then for I2, I have 4 plus 5, which is 9. And then 9 plus 3, which is 12. So I will have plus 12 of I2. And I move this minus 6 to the right-hand side. So I will have 6 on the right-hand side. So maybe let's save this as equation number 1. Because we cannot do anything more than this. And now let's work on problem A first. After this is finished, we will move on to problem B. So let's do problem A first. And maybe we should start by using KCL at node, at loop I1. KVL at loop I1. And again, the sum of voltage in a loop will equal to 0. And we will start from this one, which is 2 volt, but the current is flowing from negative to positive. So our sign will be negative and the value will be 2. And for this 2 ohm resistance, we multiply it by I1. And then for this 5 ohm, similar to previously, we multiplied by the current. But now, because we are working on I1, so we write this I1 first. And then the current that pass through this 5 ohm resistor, but to the opposite direction, will be minus I2. Okay, we have all 3 components sorted out. And then the last component here is a dependent voltage source, and the current is flowing from negative polarity to positive polarity. So I will have negative sign, and the value is just this one, which is 2I2. And all of this will equal to 0. And let's do a little math here. So for I1, I will have 7I1, yeah, because 2 plus 5. And for I2, I will have what? Minus 5 and then minus 2. So I will have minus 7 I2. And then on the right-hand side, I will have 2 because I'm moving this one to the right-hand side. So I will have this as equation number 2. So we have this equation number 1 and this equation number 2. We should be able to solve that. So I will have I1 and I2. because I do not want to deal with fractions and all of the decimal, I just plug it into calculator. Okay, so let's do the equation thing, and that is number 1. And from the equation 1, we will have the coefficient of I1 is -5. So let's plug in -5 and 12. And then on the right hand side, we will have 6. And then here, for the second equation, I will have this one, which is 7. And then -7. And then 2. So the x value will be I1 and the y value will be I2. So I have this x value, which is 1.35. Okay, so I will have 1.35 ampere. And then for I2, let's see our calculator. So I will have 1.06 ampere. 1.06 ampere. And this is the answer for problem A. We are asked for I1, right? So this is the answer for that. Okay, now let's move on at note B. I mean the problem B. So we will have this similarly. Let's do KVL at loop I1, but for problem B, and that is the sum of the voltage in a loop will equal to 0. Okay, so this one, we will start with -2, and then plus 2I1, and then plus 5I1, but I2 is flowing to the opposite direction. And then this one will be minus because that is negative polarity, and the value will be 2Vx. And all of this will equal to 0. And we will do similar things by adding this 7I1 minus 5I2 minus 2Vx, and all of that will equal to 2. And what is Vx? Okay, let's take a look at this circuit. So Vx here is the quantity of the voltage here minus the voltage here. So we can draw the current here, but this current here is I1 minus I2. So we'll have Vx is equal to I1 minus I2 multiplied by 5. So now let's plug this into this equation. So I'll have 7I1 minus 5I2 minus 2 multiplied by 5, that will be 10. But I will have I1 minus I2. So all of that will equal to 2. And we can simplify this. 7 minus 10 will be minus 3 I1. And then this is minus 5 plus 10. That will be plus 5, right? We have plus 5 I2. And all of that will equal to 2. Okay. So now we can pair this equation with this one. So we can get that I1 and I2. Okay, so now let's just plug it into calculator. Okay, let's clear this up. And for this one, I will have minus 5, and then 12, and then 6. And then the second one will be minus 3, 5, and 2. So I will have this x will be 0.546. Yeah, 0.545. Okay, 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, 4. 4, 5, And then for I2, I will have 0.72 repeatedly, right? Yeah, I think so. So all of this in ampere. So maybe let's make it in milliampere. So I'll have 545.5, yeah, milliampere. Yeah, I think that's okay. And then for this one, I will have this 0.3 milliampere. Oh, okay, I think I need to move this a little bit because it's okay. Skip. Yeah, so the answer for problem B is this I1 will be this value here, which is more or less the same as the answer key. And hopefully this will help you to solve the problem. Thank you. Bye bye.